just just FYI, for this week and next week, I'm gonna do my best to try and be responsive to email as I have been in the past week. I think I've answered emails from 4 a.m. to 11:30, like all within the hour. I've had like lots of email exchanges, and I'm gonna try to like constantly try to be there for you, like whenever you need it. But I wanted to set the expectation that I can't do that for 10 weeks.
Yeah, I think that we should all set the expectation that we shouldn't be emailing you at 4 a.m.
And so just know, like I'm pretty responsive on email, but like over time, I'm not going to be like as quick, but just keep the emails coming. Like, don't worry about it. One thing I do want to try and do, and I don't know if we'll be successful, is I wanted to try and encourage people to like work together and learn from each other. And so if you go to the class Google Drive folder, which I'll send the link out again, there's a roster file, which you guys have seen before. And in here, so this is the folder, this is the file I'm referring to, regression class roster. This is everyone's name and email, unless people's name and email are not here or they're wrong, you should fix this. There's a Q&W sheet for questions and who. So like I figured one thing that might be useful is if I've answered someone's question, it might be useful if I said like I covered this in lab. And so if you wanted to look at the lab video, you could. Or if I could name the person who asked me the question, then you'll know like who you might want to reach out to, unless the question is different. Of course, even if someone has asked the same question, you can feel free to ask me too. But I figured this would be like a good way to help people like talk to each other and learn from each other. And you know, I'll just like add names as I go, right? And I don't know if it'll be like super useful, but I wanted to try it. So it'll be here. If you want to like opt out of it, like after you've asked the question, you're like, I don't want this question made public, then let me know and I won't put it in here. So as I'm going through emails, as I'm having different one-on-one conversations, I'll try and update this. And if it looks like a lot of people are having trouble, I might make like a tutorial video and then upload it somewhere, so it's like there for you to see. Anyways, so it's here, but just send me emails. Just FYI, the problem set is going to get harder for this week, a little bit more for the next week. Week 3 is going to be like a harder week. And then it's going to start to level off and then like drop off in terms of its intensity. But it's these early weeks that are really hard. So I'll try and be responsive and supportive. Okay. One thing I will do also is inside the folder on Google Drive. This is the same folder we have for class. Like last week, it's not in here. It's not in here. I'm gonna put in some lab notes. And my computer is slow, so I'm gonna get it replaced, but bear with me as it moves along. So that if I type in new pieces of code and you didn't catch it, or maybe you think you wrote it wrong, you can copy and paste it from here. But there won't be a big need for this, since a lot of the code that you need is already in the do files that are on Canvas. But I wanted to have this just in case. So lab2 notes. I am unable to monitor the chat. And so if you have something, if other people are reading the chat, let me know. Or just unmute, it's totally okay. Okay, so before I get started, any questions from last week you think that are not code related that you wanted to talk through, or should we dive right in?
If I have conceptual questions based off of the readings, should I refer them to you or Greg?
I think like either of us would be fine, but we can probably cover those at the end of lab, or like on a different time, like during office hours, or you can of course ask Greg.
Okay. Would like during the Friday office hours probably be a good time because I don't see any time at the end of lecture.
Yeah, I think the office hour is good, or just you can also set up a time to talk to him separately.
Okay, thank you.
Okay. So I'm going to get started. We'll see how it goes. Hopefully it goes okay. Let me know if anything is uncomfortable or not readable, and I'll try and fix it. So I've tried to make the font bigger. Can you guys read this? Yeah, okay. If you are not comfortable using globals, that's okay. Just use CD, which is short for change directory, and then choose whatever address you want and load in your file and work from there. And of course, if you want like a different tutorial on using globals so that you can make it work for you, just let me know. In the last lab, we covered like writing do files, exploring the data, cleaning and analyzing the data. And I just wanted to make sure if you had any questions from last week's code or problem set that was hard to understand. And we'll do a quick review. Okay, I'll just keep going. Some of you might have noticed, but when you were creating dummies, there were missing records that some of you guys caught, some of you didn't. And so it's really important to like keep track of the missing records. And when we create dummies for the problem sets or for the lab, we're going to use a D prefix for dummy to make it a little bit more obvious. But of course, it's completely optional and you don't need something like that. And we try and give dummies more intuitive names like D white for dummy white. And when you create the variable, and let's say you start with giving everything a missing value, and you give everybody a 1 if race is 1, because the first race up there, 1 is white, and you have to give someone a 0. A lot of you guys did this where you said if they're not 1, meaning if they're not white, give them a 0, meaning untrue, they're not white. But you didn't check to see what happened to the missing. So if I do this, and now I tab D whites, and I cross tab race and D white, you'll find that people who we didn't have information on for race, they got a 0. And that's not okay because we didn't have any information about them. And so we should continue to not have information about them. And so what you could do is you could say replace D white is equal to missing if race is equal to missing. Or what you can do is when you first set the 0, you can say replace white is equal to 0 if it's not equal to 1 and if race is not missing. And we'll do that for all the other races. Some people missed that for Hispanic. There were 2 groups of Hispanic. There's Hispanic race specified, Hispanic race not specified. They are still Hispanic. And so you want to make sure you've captured both groups. And every time you create a dummy variable, just keep checking the tabs for the original categorical variable and make sure that the numbers work, right? In here, we know that we should have seen 55% white, 15% black, and so forth. So when you do a summary of all of your dummy variables, they should be identical to sort of the percentages that you're seeing here. White, 55%, D white, 55%. And if they're not matching up, that means something went wrong with the code. So like always double check. And because we've used these dummy variables, D white, D black, D Hispanic, D Asian, D other, it's useful to create a simplified race variable that kind of matches this. The current race variable is much more specific. It has like 8 different categories. We're only using 1, 2, 3, 4, 5. So we want to create a categorical variable that matches our dummy so that we can refer back to it more simply. So that's what I'm doing here. I'll generate it, fill this in, define the label as you've seen before, and make sure that I've done that right. Let's say tab rate simplified with the whites. And that works, except I don't know what happened to the missing. I see. I think for other, nope, sorry. Oh. All right, I'll do this the other way around, where we can see white matches up with white, black, black, Hispanic are now those two groups, Asian and other. Okay. So just a quick review. You've seen this, you've done this, and what I'm going to try and introduce to you today is loops. Because there's a faster way than writing one line like many times over. And so if I wanted to check race like how I did here, and I want to check one race at a time, like I might have to write like tab the white race, tab the black race, tab the Hispanic race. You just have to type it out again and again and again and again. But if you use a loop, what you can do is you can say, for every variable of a variable list, and list out the variables you want, you can then say tab race with this weird looking green variable here. And I know it doesn't make, so it means to a simpler loop. Let's say what I wanted to do is just tell me like with display. Display just means print something onto the status screen. So if I say display Paul, it'll show me Paul. If I say display whatever I want, it'll show me this. So in this first loop, I'll just say print for me display, like all of the variables in my variable list. And this is what's going to happen. It's going to go through this variable list, display, and where it says var, it's going to plug it in and basically run display the white. And once that's over, it'll display the black. Then once it's over, it'll display the Hispanic, the Asian. Question?
Yeah. So that keyword var has to be in 3 quote or the double quotes and then the single quotes.
Yeah. So
because that can get really confusing.
Yeah. So this var here. This is a weird thing to type. This var, and just mind you, this can be whatever you want.
Mm-hmm.
And the way you get this is it's called a backtick. So on your keypad, next to 1 is tilde, and under tilde is this like little tick. So on the left side, you use that, and on the right side, you use a single quote. So it's not single quote, it's backtick and single quote. If you did single quote, it would look like this, which is not the same thing. So this little piece is different. And the reason why I have double quotes is because this is kind of a string. And for me to display a string, I have to put in double quotes around it. And let me get rid of this now. And so I can say display variable, but now I can also say tabulate race with each one of these variables. Right? And it's getting longer now, but the first thing it did is it tabbed race, which is here. and then D white, which is here. Next, it'll go to D black, which will tab race here, and D black here. Is the for loop kind of making sense? Are people confused? Looking good? Okay. There are many types of loops. We're just covering for loops, which get used often in data science. There's like a while loop and an until loop, which you probably won't need. Yeah, question?
So I have just a basic coding background. So like because with every for, like there's the end of the loop. How do you designate the end of the loop?
Oh, right. Good question. So the start of the loop is this squiggly line here. And then the end of the loop is this squiggly line here.
That makes complete sense.
Yeah. Okay. So in Python, like you don't use these squiggly lines, you just use a tab. I think R also uses squiggly lines, or squiggly brackets. But this is the start of the loop. This is the end of the loop. And Stata has different ways of showing for loops. For loops are just basically do something for every little piece that I have listed. Another way to do it is this, like for var. And again, this piece, you can call it whatever you want. Instead of var list, you can say in, and it'll do the same thing. So for var in whatever you write, for each of these separated by a space, it's going to take these actions. Okay, something is blinking. I feel like people are, okay. They're identical, except this here for var in is more flexible in that this doesn't have to be a variable list, right? Like if I say for each var a variable list, whatever comes after, it has to be a variable in your data set. But if you say for var in whatever, it'll do whatever it asks, regardless of whether it's a variable list. And that's kind of like a minor point, but it becomes important as you code more. So I'll uncomment this. If you look at this, for each var of var list, something, right? These are identical, except now I'm using in on top of var list on the bottom. This worked. This is not going to work because this something here is not a variable. And so depending on what you're doing, this will matter a lot or not. But if for now, you can use either or as long as you know that whatever comes after is a variable. So this second one, the one with the in, without specifying variables, it's more flexible, but it costs more computing power for Stata, so it's a little bit slower. But you won't notice it because it's really fast on a smaller data set. But that's sort of the basic anatomy of a for loop, and we're gonna like continue to use it. But if for loops are becoming like too much for you and you want to just write it out, you can do that. That's totally fine. It's just for coding efficiency. Okay. Questions before I begin to move deeper into loops?
Sorry, can you give an example? Maybe you did. I might have missed it. Of when you would use the one without the var list.
Yeah. So it'll come up. Maybe let me scroll. Let's say. Okay. So sometimes variable names, right? They look like each other, but they only vary by one component. In which case you can say like for each something in say 1, 2, 3, 4, 5, display. We'll summarize it. We'll summarize math something. Now, this is not a variable, right? So you can't use var list. it's just gonna break. But you can use it for something like this, where it like uses will come later, but for now, for a lot of what you have to do, you'll be okay just using whichever one you need. I think over the weeks, I'll show you different ways in which it becomes useful. If this isn't useful now. And the way that we've created race variables with the way we did it up top, there's a shorter way to do it. Like when we tabbed race last time, we could try and ask for a summary of the, let's say math one, right? And so tabulation, the command has another option where you can generate something. So let's say we use tab race, gen d race. We can see from our variable list that it's created these variables, d race 1, d race 2, d race 3, and so forth. So with one line, you can create everything, except these are not good names, so you would have to rename them, right? But what's nice is if I tab race and d race 1, and d race 1 is white here, it knows that when the categorical variable is missing, the dummy that it generates should also get a missing. So you don't have the problem where you have to remember the missing. You just have to rename them into something more friendly. But you know, it's not the best name, so we can just ignore it. I think we can skip this. So we can do, there are like other ways to continue to use loops. If you go to your variable lists, which I don't know if it's showing up here, right? There's a lot here. And let's say you don't want to type out all of these, but you want to take an action from variables that start from here all the way to here. You could copy and paste it, right? Like I can copy and paste this here. And it'll tab the race with the variable listed here. Or I can say from this, go to this. And it'll just take from this variable position to this variable position. So these are just shortcuts, which you don't have to use, but it's here. Just make sure, but it doesn't care about what the variable names look like. It'll just take any row. So if your variables are ordered in a different way, it might mess you up. Another way that you can think about using for loops is, and I think this was the example I sort of showed. You can say like for d race, which we know, we have variables that end with 1, 2, 3, 4, 5, 6, 7, 8. We can say tab race, d race, and just change the last piece of it. So for each, we'll call it I, in 1, 2, 3, 4, 5, 6, 7, 8, do this action. And it'll take 1, run this line, then take 2, then run this line, and so forth. So a lot of this you don't have to know, so I'll just quickly run through them. But they're just all the ways in which like loops can kind of help in different situations. And for each loop is the one you'll likely use most often, but you could also use for values. So like in for each var of var list, where you are specifying that it has to be a variable, which allows you to do some stuff, you can say for values, and it will make sure, and you're specifying that it's a number. So instead of saying 1, 2, 3, 4, 5, 6, 7, you can say for every I, which equals 1 through 8. In English, that would be 1 through 8. In Stata, that's 1/8. Same thing. But this was just sort of an illustration of loops and how you might make it work. But we don't need these d-race variables because we've already created them. But sometimes, like a variable like this, which has intuitive numbering, right? First quintile is 1. This tab way of generating variables could be useful because then it'll create, right, DSES1 for the first quintile and so forth. So sometimes this is useful, sometimes not so much. And it'll just all depend on the variable name. And we can check, right? As we have noted, if you're in the first quintile, you get a 1 for SES1. And if you are missing on the categorical, you get a missing on the dummy. And we can define it, label it, and it'll now show up as, instead of 0, 1, no, yes. So loops are useful. It'll do many things for you. Let's say we want to describe the outcome of externalizing. Right? We have 1, 2, 3, 4, 5 variables on externalizing. And let's say we want a histogram and we don't want to write down histogram variable like 5 times. We'll just do this. And remember that for histogram or any kind of graphing, if you don't want the graph to disappear, you have to give it a name. So we'll give it a name, call it hist underscore, and we'll give it the variable name. And we'll make sure it can overwrite it if we run the loop multiple times. I'll make sure that we're thinking about the missing values because we know that sometimes it's not showing up here, but sometimes we might get negative values, which are indicative of missing, and I don't want that. And this one other thing, which has this star here, you might be wondering about. It makes it so, I think we covered this last time, but I'll cover it again. Let's say, if you wanted something, right, call multiple variables that share a similar name, you can use an asterisk. And what it'll tell Stata to do is give me everything that has and ends with extern, but it can have whatever it needs to be in, like before extern. So it could be longer, doesn't matter. It just means the variable name starts with something, but ends with extern. So this would be equivalent to sort of doing this. If I wrote T1 extern, T2 extern, T3 extern, and so forth. It's the same.
Can we also put a star at the end of extern if we're looking for words that come after extern?
Yeah, and you can also do this. Right, like it has ext somewhere, it has ERN somewhere. So I'm gonna run this. Something's blinking, question. Okay, cool, yeah. And my computer's slow, it's generating a histogram. It'll come up. And the question I have for you is like, what's wrong with this graph? And you can run this on your own too, right? And I'll cycle through. Like, what's, this is externalizing, showing histograms across multiple periods. But something is not right. Can anyone see?
Why
It's not. Sorry.
I was just gonna ask, like, I see in some of the histograms, maybe I'm not reading this right, but some of them, like, why is there spacing between some, like there's no data, and then, well, maybe that's just because of the points, but if it was doing the data, shouldn't there be a histogram at each point and not like weird blanks between the points?
Yeah, so we can look at, let's tab extern. So as long as there's, like the way a histogram works is it creates these buckets, right? From one X value to another X value, and it's uniform. So sometimes if there is no data at this data point, then it won't show anything. And that's sort of particular to the data. And that's okay. Does that make sense?
You can change the buckets, right?
Yeah, you can change the bucket size. You can make it fatter, you can make it thinner. If you want it super thin, you might as well just use K density. But there's something I want you to notice as you're creating figures. And I don't know if anyone's caught it yet. Make it more obvious.
The Y is changing the.
Yeah. Yeah, the Y keeps changing. And if the scale is different, it can be really misleading when you're exploring with the data. And so you can have And Stata has really bad graphing capacities. And so I won't go through all of the like graphing tools, but I will go through some of them because they're like somewhat useful. But just know in advance, for graphing, R in Python is much more effective, but Stata is not terrible. So I'll add some code here, and what you can do is same thing. I'm sure people are saying, okay, they're okay. Yeah, ggplot is okay, not, but it's better. So you can say like, you can change the width of the bars by specifying W, and you can specify the y-axis by saying y label. And the way to read this is start from 0, go to 30 in increments of 10. It's just kind of weird, but it's just the way they do it. And if you forget, which is often I forget, you can look in the help menu. And as you dig deep, when you go into like, when you click on these extra options, you will find these things, but they're not all in like one neat place, which is really annoying. But usually what people do is they like figure out a way to graph something, they save it somewhere really important, and whenever they need to, they just go back to that code. There are like cheat sheets that kind of help you understand graphs, and I'll post those too. But once you do this, and you can kind of like these are kind of in the same scale. And instead of density, it's now using percent. And the difference between density and percent is a little bit nuanced. They're similar. You don't really read density. What density does, it just takes everything that is colored, right? All the bars, and treat that as one. And it says, what is the portion that it takes, which feels like percent, but it's not. It's weird, but you don't have to worry about it. People don't report things that way. You can also do like a t-test of multiple outcomes. Let's say you don't have just externalizing outcomes. Maybe you have like 50 outcomes. Maybe you'll do a t-test for that variable by the whatever group you want.
Oh, I think you muted.
Oh.
No, you're not muted.
It says you're not, but it's I hear the mute.
Can you hear me now? So people can hear me?
We can hear you.
Huh.
We can hear you.
Me. Okay.
Okay, cool. All right. So I've made this t-test, something that you will learn to abandon, but you can quickly tell like this is not friendly to read, right? Because when you output stuff in loops, it doesn't print the code right above it, right? It just prints this code. And so it takes a long time to figure out like what was this about? Like which variable? And you could remember that this is probably externalizing and then look hard for it. But you can get Stata to do things for you that's a little bit easier, just not coding wise, graphically and visually speaking. Like what would help you read this better? Anyone?
Maybe in a table.
Yeah, we can put it in a table. We'll get to that later. But like just when you're printing stuff, like you just want this to be a little bit nicer. So like maybe, so I printed codebook here, but maybe what I'll do is I will display some line. And it's kind of helpful. It changed, this tells me something above it and something below it are different, right? Like it's run one thing, it's printed this line, or it's printed this line first, and then it's run something. You can make it a little bit better and say, well, let's display nothing and just give me like line breaks. That's a little bit more helpful, but then you might say, let's display more stuff like below is about variable. And then it'll do something like this. So as you're working with data, it can be really uncomfortable. So you have to make it more comfortable for you, right? And you just have to think like, what do I want? Like, I want more lines. I want something more descriptive. You know, and this kind of works. This is about that. Anyways, so I wanted to timestamp here just to make sure I had 45 minutes remaining, and I think I do. And I figured since we're gonna do it for an hour and a half, we'll take like a break in the middle. But like I just like really quickly went through for loops, and just to give you a sense for like how you can make Stata do things for you that's a little bit easy. Questions?
Earlier on a loop, you always have the code comma and then name. It's in black.
This one?
Higher.
Can you give me the number, line number?
Sorry, 180.
180. Yeah, here.
So what is, I don't understand what that code name is doing.
Oh, okay. So let's take it out and then see what happens.
Oh wait, the name belonged to the whole thing in parentheses.
Yeah.
So okay, I thought the function was name is to assign a name to something, but
It is. So like if I run this, right? But can you tell me what's happening? What's different now that the names are taken out? Anyone?
It doesn't display all the histograms in that one.
Yeah, it's gone. It's gone, right? You only have the latest histogram, but you don't want to lose them. You want to make them stay so that it doesn't change it. So you give it a name, parentheses. Usually when there's a parentheses, it means it belongs to the thing that comes before it.
Okay, so we're not using quotation marks in this case because we're not actually assigning an individual string variable name. We're just telling it to name it whatever the variable is.
Yeah. I mean, yeah, sometimes it's weird. Sometimes it's like for anything like character-esque, it requires a double quote. Sometimes it doesn't. It's like, it's how they programmed it, right? So if I put it in here, like now it doesn't go away, but it just creates a new one. And depending on your Stata version, it'll just create new windows. Stata 16 creates tabs. And then you can go and like browse through.
Okay, got it. Thank you.
And this, if you go to help this, you can make it give you fractions, frequencies, or percents. And in this graph, I decided to show percents, like what percent of the data belong in that bin. But you can do other stuff. You can do frequency, like, and instead of, and the Y scale is all stuck here between 0 and 30, right? So that I'll get rid of this. And you can see that there are like, once it stops, like thousands of this and thousands of that and thousands of this. But usually numbers are not so helpful. But like, you know, the shape of the histogram is the same, but the scale can change. Okay. And I think I wrote some more stuff here. But anyways, is this a good time to take a short break, or do people have more questions? And if, of course, people want to take a break, they can. We'll just come back at 2:50. So people who want to stay and ask questions, they can. But for others, feel free to just go. All right, it looks like everyone wanted to go. Well, most people. There isn't a bad time for break.
Paul, I have a question.
Yeah.
I want to know how long it took you to get good at Stata. So this is my 4th class, and I'm not bad at it. I just don't practice nearly enough to like know things, but I can read
Yeah.
outputs fairly accurately. But
Yeah.
how long did it actually take you to, know what you're doing?
Yeah, that's a good question. Coming out of my master's program and going into RAND, where I was a policy analyst, I was not very good. And I think it's because there's a limit to how much you can learn with courses. Then I think after 6 months at RAND, which was like a ton of data cleaning, like every day for hours, like I got pretty good. And then I got better. But like being like, I think like good enough that I'm not making rudimentary mistakes, and I'm not like there's a point in Stata where it doesn't do exactly what you want it to do, and it's like super frustrating, and like you're afraid to go a different route because it's just like perplexing. That I think went away 6 months after of like doing project work.
Oh, nice. And you said you were at RAND. So what kind of professional like leeway were you given as somebody who like knew it, but we're still working through it?
Yeah, so you get more leeway than you should get. They're like, go do it. And you just do it, right? You just like Google everything that you can. And there were a lot of programmers around me, so I just asked each person every time I got stuck. And this was before the pandemic, so it's easier, right? Just pop into their office and just ask. And usually the PI or like the PhD researcher who's doing this, who's done this also for their dissertation and kind of know it better, they'll like check my work. They'll just make sure things are okay. And there's like a formal QA process called like, short for quality assurance, where everyone is checking each other's code to make sure nothing is going wrong. And there are many ways of doing that. So you get some leeway, more leeway than you would feel comfortable with. But then there are checks that sort of work as a fail-safe. Does that answer your question? Okay.
Super helpful.
Yeah.
Thanks.
Yeah.
Wait, so Paul, when did you work at RAND? Was it before your PhD?
Yeah, it was before I started. So I was there between 2015 to 2019. And I'm still technically part of RAND. Like I'm not completely gone. Like I'm like an adjunct analyst there to like wrap up some of the research I was doing.
So you were I'm just like, I'm looking, like, I'm seriously thinking about like career options right now because I don't necessarily know if I want to go into academia. And I hate to be blunt about this, but I want to get a job with my PhD that's going to pay the bills well.
Yeah. And the research organizations tend to pay more than like an academic institution. And then like so some of my friends who are like really good programmers, they ended up working at like Booz Allen or like other consulting firms that do a lot of contracting work. And they would like build tools and they do really interesting stuff. So you could like definitely move in that direction. But yeah, it's job market. It's like, terrible. So
I want to make sure that I'm like, proactive during my PhD, that I'm building the right skill set. Because while having research skills is important, I'm just like, should I be working on like side projects in the meantime to pick up those extra skills on the side instead of doing like summer GSRs or TAships? Should I look for internships? Just like, I don't really know what my options are.
Yeah, I mean, I can tell you about how like RAND does it. Like a RAND internship for PhD students is sort of like a long job interview. Like it's so like you get to know how RAND works, and RAND gets to know how you work. And what they'll do is they'll give you a pretty small project that's like narrow in scope. Like so, I think it was someone coming out of Vanderbilt. They came to RAND. And we were working on an analysis estimating the effects of like a professional development kind of program. And we were all set. Like I had cleaned the data for like 2 years. We're all ready to go. And he came and he sort of laid out analytic plans in a more organized fashion, ran some of the analysis we had ready, then presented the material. And in the meanwhile, you get like set up with the mentor who like sort of teaches you, but you're basically working for the mentor and talking a lot and asking questions and learning as you go. And at the end, you do a presentation of your work. And then like everybody in the division will like watch you present. And that's sort of the end of the process. And what you get to figure out is like, okay, this is what the people here are like, the kind of analyses they run, the way they write about things, because the way you write about results really changes. And that might be a good signal, like when they like people after they've come to the internship, then they'll try and like stay in touch with you. Or you reach out to them, they'll respond to you. And when a job interview comes, oftentimes like the mentor who was like who you were matched up with might help you on like how to do the interview well at Rand. Or like how should you present the results? Like how should you structure it? Like what are people used to? Stuff like that. I know that different people with different backgrounds, they'll get like, they might get offers from like Amazon or Google, depending on the kind of stuff you do. And that's like another way into those industries.
That's what I want to figure. That's the skill set I want to build, because my background is computer science and I would really hate for my CS degree to go to waste. So like, what does it take? Because like, I know I'm not doing like a CS PhD, so I don't know if that like sets me back from those, from jobs at like the big companies, but.
I think a lot of people, cool. It looks like there's something said here. Okay. All right. So it's 2:50. I mean, we can keep talking, but like, we'll move on for now. I'll just get started. There. Trying to set this up. I have to share my screen. Okay.
Paul, I actually had a little question about one of the codes you ran before. I think I might have lost it trying to run it myself.
Oh, okay. Yeah.
Have SCS Q5 Gen and then DSCS, like it's a little bit above. Line 157.
157. Oh yeah, okay. So the question?
Does the code automatically generate DSCS for all 5 quartiles in that code? I wasn't sure.
Yeah. So let's go there. Let me drop DSCS. Okay. So if we do a regular tab, right? You've seen this. I'll code book here. What this will do for Gen is it's going to create a variable for each of these values, starting with DSCS, and it'll add this numeric value at the end of it. And it'll do it for each of these. So if I, like, the describe tells me this is sort of the end of the variable list. Like, this is a friendlier way to see it. Is here. If I run this code now, right? This is the bottom of the variable list. If I run this code, it's created 5 of these, and this explains to you which ones it's created.
Oh, so that works for categorical variables. If I have one in front and then do gen whatever I want, then it will generate the variable for each category.
Yeah.
Okay.
Yeah.
Thank you.
Yeah, and it'll like code the missing appropriately so that you don't have to track those. But you should double check anyways. But
okay, thank you.
Yeah. Cool. So we're finally getting into bivariate analyses, something you'll have to do for your stuff, your problem set. So we can like just quickly look at, let's say, 2 variables, read 1, math 1. These are test scores at fall of kindergarten. We'll look at a scatter. It's not pretty. This is the missing stuff, right? And you can tell like it's a positive relationship, right? Meaning like as you go to the right, it goes up, right? It doesn't look like this. You can't really tell how many dots are in each place. And the relationship is not so strong for the scorers, for some scores. Like this is probably a stronger relationship. Over here, like after like 55, the relationship's kind of weird. You can't really tell. but like the zeros are kind of weird, or like the negatives are kind of weird. So we can scatter with an if statement, like scatter this if, you know, both of them are above 0. And we'll give it a name. We'll just call it S1. And it's the same thing, just without this little missing stuff. And we can use a loop now. And maybe what we'll do is let's look at a scatter. And so it's the same thing. Scatter this. Make sure you get rid of the missing using an if statement. And do it when one of this for white students, Black students, Hispanic students, Asian students, and other race students, or other race/ethnicity students, right? This race comes from this race of the for loop command. And I will give it a name so that it doesn't disappear. Call it S1 underscore for race. And it will generate a scatter plot for every race group. That's kind of nice. It's a good way to get a feel for them. You can tell like there are not a lot of students here, more students here and here, right? It just tells you about the sample. And you can make sure that the scaling is correct, so that when you are comparing things across the histograms, they're of the right scale, if they're easier to compare that way. You can put the scatter into a number by using correlations. And I'll stop and ask, like, what does this suggest? Something's blinking. I can't see my chat window, but
A strong positive relationship between reading and math scores.
yeah, sure. But what does the scatter suggest?
It's not on the screen.
Oh, sure. I'll put it back on the screen.
I would say that it suggests a lot of variability.
Yeah, there's some variability, right? So the statistic is kind of useful. You're like stuck with one number, so it's not fully descriptive. And maybe what I'll ask you to do is, can you look at the correlation between reading and math score at each wave? Over here, we've just sort of looked at it on one wave. Like, if I were to ask you to stop and code, and I'll give you like 3 minutes, maybe 2 minutes, like how would you get the correlations for every data collection wave?
Use a for loop?
Yeah, just use a for loop. Just try doing it. See if it's like comfortable enough. Just wanted to give you time to try and write it. If you don't get it, that's okay. I'll show you what the code looks like in a bit. Okay. Cool. Was anyone able to were you guys able to code this and try and do this with the for loop? There are different ways of doing it. You could use a for value loop, which you're probably not used to. What you need to change is this piece of the name and not the full variable. So you do something like this. This was equivalent to saying for each I in 1, 2, 3, 4, 5, 6, 7. These two lines are identical. So if I run this, it'll tell me, because I've said line break, tell me the wave number, correlate, read I with math I, given that they're all non-missing. And it gives you this, and from year to year, the correlation gets weaker, and then it gets stronger. Why? I have no idea. One useful thing I forgot to mention about correlations, which is like rho. If you have a correlation of say 0.72, it means that 51% of the variance can be explained, like 51% of the variance in read one of your variables, this sort of the variable on the y-axis, can be explained by its relation with math1, which is a variable on your x-axis. Because the correlations are using like standardized forms of the variables, you can basically just take the square of the correlation coefficient to get the R square, which tells you the amount of variance that are explained. So that's a fair amount. It's like another way of thinking about the correlation statistic. Like this is informative enough. It's another way to read the same thing, just with different language. And let's say now, like what we can do is like look at the relationship between SES and externalizing. We'll look at it in scatter. So for each variablist in all of the externalizing variables, I'm going to scatter one of these variables here with SES. This is the continuous version. As long as it's not missing, right? It's greater than 0. And I'll give it a name so it doesn't disappear. And I'll give it a common y-axis. And this is kind of an interesting where, like, what do you think about these graphs?
They could be more legible with a different graph.
Yeah. Like it's not, there's scatter there. It's like a big circle. It's really hard to see the patterns, right? Because they're like overlaid on top of each other. And we'll learn like a different way to graph it in Stata, where you can like create bins and show averages. But like sometimes this is why like correlations is helpful, because this doesn't give you a lot of information. You know, you're not left with a lot to work with here. And so instead you could do the same thing, same loop, but except now you will show correlations. Core and PW core. PW core is pairwise correlations. Mostly the same. And what you can do is you can give it a star if the correlation is significant. And it's a little bit more helpful, right? It tells you like the correlation between SES and externalizing is negative. So if you have more SES, higher SES, you have less externalizing, which I guess is intuitive, and it's significant. And this is pretty weak, right? 0.1 or 0.1 something. And that's kind of reflective of the scatter. So maybe it was telling you something, but it's hard to tell. This is where like scatter gives you a lot of information, but like sometimes it doesn't, it's not clear, and correlations is kind of useful. But for correlations, you don't really need a loop. I just did that to like show you. You can just put them into a list and it'll give you the exact same thing, and this is much better than what was up here. And let's look at like approaches to learning. Like I look for learn, right? There are these variables on approaches to learning. And I'll ask, like, some of them have a P in them. Some of them have a T in them. It's because P is for parent and T is for teachers. So parents say, here's my child's approach to learning. And then teachers say, here is this student's approach to learning. Will they be strongly or weakly correlated? Yeah.
Well, I have a question. So like I tried writing the for loop in the without doing it in the do file in the command line. Is there a way you can do it in the command line? Like
you can. So you can say like for each, let's say X in 1, 2, 3. Okay. And let's say I press enter.
Okay.
Right? It's now asking me to like continue coding, and I'll say display
okay.
X, and I need to end it, and then it'll run.
Got it. Thank you.
And depending on the version of Stata, you can and cannot do this. I don't know which versions in which you can't, but you can with the newer versions. Okay. So any guesses as to whether approaches to learning will be strongly or weakly correlated?
Hopefully strongly.
Yeah, so I'll run it. Right, you're gonna kind of getting a sense for the correlation coefficients here. And what do you think?
There's no correlation.
It's pretty weak. It's pretty weak, which is kind of surprising. You would expect like, well, they're the same child. Yeah. So like when you're measuring something, like who the reporter is going to matter. I want to make sure there didn't miss anything. Okay. And now we sort of move into the world of regression, where you think about the scatter and then a line. And to sort of show that graphically, you say scatter, right? Read one, math one, this weird like parallel line, and then say fit mean line fit a line that shows the relationship between read one and math one. And this if statement is just to tell me, get rid of the missing stuff, and I will give it a name so it doesn't disappear. And it's kind of there. It's somewhat useful. It's a way to like think about this relationship in a line, but it should tell you, right? Like you should be suspicious of the line. It might describe this pretty well, but not this, right? The linear relationship here is going to be more valid than the linear relationship here. It's like not really data-based. Okay. So in our like last example of like looking at simple regressions, we're going to be using math 1 and math 2 as examples, and I will just clean them up because, as you might expect, math 1 has missing values, so I'll get rid of them. I'll give it a true missing with a dot. I'll do the same thing for math 2. There are different ways of recoding this, right? You can specify each value or just give it some kind of an inequality sign. And now I'll run the regression. And this is something that we sort of did in class using dummy variables. And in week 1, we read Greg's like old paper from like 30 years ago. And what I'm asking you to do is like, what does this number mean? Or what would you say about it?
Can I ask a quick question, Paul?
Yeah.
So the one vertical line means or. What does two line mean again?
This is used only for graphing, where it just says like do two things. There's another way to do this, but it's saying like, give me a scatter, but I need it to, lfit is another command, right? So I need to tell Stata that whatever comes after is actually a new graphing command called lfit. And so this just
use it to separate two graphing commands. What if I had a graphing command in the front, but then
you can switch this and it'll be the same.
Okay, thank you.
Like you can do this. By the way, or maybe LFIT is part of scatter. But this is really only used in graphing and not used in other stuff. This I think is, I'm pretty sure this is data specific. Like this is programs like universal, like people use this everywhere, whatever the language. I think this is unique to Stata and unique to Stata graphing.
Okay, thank you very much.
Cool. So go back to this. When we regress math2, which is your y variable, on SES, which is your x variable, it's going to give you these numbers. We didn't cover this in class. I don't know if we will, but I can cover this later. These are all things you will learn to like read. But for now, this is what matters. Can someone interpret this one?
That means by every value that the SES goes up by 1, math2 goes up by 6.06.
Yeah. That's exactly right. And I will put into the do file like different ways of expressing it. Like you can, it's all about a 1 unit difference in this variable, your x variable, and how that relates to changes in your y variable. You can say, this is like the strangest way to say it, like 1 unit difference in SES is positively associated with 6.06 units difference in math2 on average. It's like a really weird way to say it, but it's just, it maps on more directly, so it's sometimes easier. Just know that you need to add this language on average, which I'm sure might have been drilled into you during fall quarter, but it's because you're making an interpretation on the sort of the expected value of y and the expected relationship. Some people will say like this is sort of a friendlier way to say it. Students with higher SES by 1 unit scored 6 whatever units higher on the spring math test, right? And going away from this like technical jargon and closer to sort of a standard English version is not easy, but it's sort of thing you will want to practice because you do not want to sound like this. You want to sound like this so people understand you and you can communicate better. You guys have probably seen the R squared and it's sort of been explained a little bit in class. Just the number 0.16 is same thing as 16%. Means 16% of the variance, right, is explained by its relation to SES. And as you add more stuff, right, Greg kind of mentioned briefly that as you add more control variables, these things change here. And I want to, and this is something I think you have to know for the problem set, is what happens if you add in the control variable, and what we will control for is your prior math score. Like, what do you notice that's like important?
The standard error is smaller.
Yeah, the standard error is a little bit smaller. Anything else?
The R square shot up to 69.33%.
Yeah, so you're explaining more of the variation because you know more about their math score at a previous time. Anything else? Any big differences between what's up top and what's on the bottom?
The coefficient decreases by a lot.
Yeah. Like there's this like huge relationship with SES, right? And math2. And just like suddenly drops like something like 1. Which makes sense. We know more about the student's math score. And also like it's kind of crazy how it maps on like your previous math score of 1 point difference is related to like a near 1 point difference in your next math score. It's kind of great. I don't know. For me, this is always kind of surprising, like how closely related the 2 math tests are.
Can I ask a question, Paul?
Yeah.
Just to double check on that regress command. So the y variable always goes, the outcome variable always goes first. Can I add in an unlimited number of predictor variables after it then?
Yes.
Okay.
You have to be careful about your degrees of freedom. It's very closely related to your number of observations. But like the more variables you add in, the more degrees of freedom you use. And so if you have a small sample size, let's say you have a sample size of 50, then you should not, and then your degrees of freedom, I think, is like what, 49, right? So for every variable you put in, you're estimating a new parameter. So like things like these are all parameters, right? And so you can't put in as much as you want. But in a large data set like this one, you can put in as much as you want because you have a lot of degrees of freedom. So like if this was sort of the language, like using this kind of language to describe this simple regression, if we add in a control, how do you interpret this 0.9? We know that here, when we do a simple regression, a change in X, meaning students who are 1 unit higher in SES, and these are like meaningless units, right? They're just some number that someone came up with. They scored 6 units higher on kindergarten. If you add in a control variable, what does that mean? And how does that change your understanding of this 0.9?
Are you asking for us to interpret it with the additional variable?
Yeah. So I'm asking you to interpret this result and specifically this one.
So it's well, based on the last chapter, it's the same interpretation, but you just have to say while holding the other variable constant. So in this case, it would be holding math constant.
Yeah, and you would be technically correct, right? You are holding math 1 constant, and holding math 1 constant, this is the relationship between SES and math 2. But what does that mean to hold something constant? Like substantively, what does that mean?
So in this case, are you controlling for maybe gap scores, like people who are, I think in the example that he used, I think if some people got 110 and they started out at 108, that's not a big thing. But if someone came from a 95 to a 10, so you can control it for those. Is that what you? I don't know what you.
Yeah. I mean, you guys are both saying something that is correct. Like you're controlling for prior year, like math score. So, like, but it's this drove me crazy for a long time. Like every time when I was learning regression, I would ask like, what does it mean to control for that? What does it mean to hold that constant? And people would just give me more technical jargon. It'd be really hard to understand. Like, what's happened, right? Now that you've added this information, like what, like it's, I don't know, like maybe you guys like grasp it like readily, but for me it's like really hard to like understand, like what does it mean to hold that constant? And it took me some time to like figure it out. But I was just wondering, like, without using technical jargon, what does that mean?
So doesn't that mean that the students with same math scores from different SCS, so we are analyzing that way? So we are seeing,
Yeah, that's pretty close. Yeah, like because people with different SES is gonna have like they're all gonna have different math scores. Even for the same students, maybe we can scatter this, right? Scatter math 1. For the same student at SES, there's this huge variation in math skills, and maybe in math 1. And so what controlling for math 1 does is you're comparing students with similar math scores, because that's a better comparison to understand the relationship between SES and math 2. So in an equation form, you might have like y is equal to, I won't use y, I'll say math 2, right? equals A0, some constant, then some beta 1 for SES, and then an error term, right? And I'm sure in Drew's class, you guys, like I'm sure he drew like compounds everywhere, right? Like you have something that affects SES and something that affects math, and that biases your estimate. Another way to say that is that compound is in this error term. So this error term now is related to your SES and is related to your math. That's the confound in the equation form. And so what you do is out of this error term, you bring out math 1, because math 1, I don't think it will change SES, but you might have a variable that changes SES and math 2. It's now taken out of the error term and brought here. And what this allows you to do is you can now compare students with similar math scores and then look at the relationship between SES and math. And this is why it shrinks so much, because a lot of SES was confounded with math 1. And now that you have that controlled for, now that you're making a fairer comparison, right, of students with similar math scores, what is the relationship between SES and math 2? It's much smaller, it's 0.9. So like in the technical jargon, this is what we've been saying, right? Every 1 unit increase in SES is related to 0.9 units increase in math 2, controlling for math score, or holding or holding it constant. But sort of a non-precise but intuitive and conceptually correct way to think about that is you're comparing people who have similar values on these control variables that you are putting in. This is why you're able to better isolate the relationship between SES and math. So the more variables you have here, the better you're able to look at this relationship. But because it's so long to say it that way, right? People just use the shortcut and say controlling for, holding constant. And it sort of does the job. So that's sort of the end of covering the new content. And we can do like a quick practice for whomever has time. But before I move on to this like practice that you can try and do, and and this is sort of like asking, do the number of siblings in your house, or siblings that you have, significantly predict math 2? And then specifically I'm asking like, how does the association change when you hold SES constant, or when you control for SES? What if you hold mom's first birth age at which the mom had her first birth? What if you control for that? What are other control variables that could meaningfully change the direction of the relationship between the predictor over here, number of siblings, and outcome? Does it does it like, you know, like as you sort of think about what are relevant control variables? So that's sort of the practice question I had. I don't know if we'll have time. If people wanted to like stay on and like try and do the practice, like I won't reveal the answer until like you've like gone through it, and then we can walk through the results. And like more examples here, which you don't really have to read, but like it'll all be in the do file that I post. But for now, I'll stop and ask if you guys have questions.
Just to clarify logistics, so after saving this file, ideally the one that you uploaded for our homework for PS2 file would be the saved file, right?
Yes. So this other do file that's on my other screen here, the one that ends with PY, it's just my initial. This is the complete one. And at the end of this, I save a file called for PS2. I upload this file on Canvas in the files page so that you can download it and not worry about producing the file that you need. Someone used the wrong data set for their problem set. And so I had to look at their code to grade. And they did fine. They did fine. But just please make sure you're using the right data. And it's all on Canvas.
And then you said you're uploading the PY file at the end of class?
Yeah, like probably in the next half hour, I'll upload it.
And that's the one that has everything.
It's gonna have everything.
Perfect. Okay, thank you.
And I realized I wanted to go back and forth between like here and dropping in code into the Google Sheet. And I realized I didn't do that, sorry. I like started to forget, but anyways. Do you guys have questions on the code, the output, or the problem set, or anything? Okay.
I was just doing the problem practice questions you have on the do file,
Yeah.
the number of siblings. So I got the results and I'm not sure if I'm interpreting them correctly.
Yeah, we can take a look. Before we like turn to the practice questions for whomever, I'm going to be holding group office hours tomorrow from 2 to 3. But like I didn't have time to do like another survey to sort of see if that works for everyone. If that's not a good time for you, like I can hold another group office hour on Thursday. Yeah, I'll somebody wants us, yeah. So Fuko, yes. But let me know if you think Wednesday is not going to be good for you. Then I'll hold another one on Thursday. Other questions that come up during the problem set, just email me. If you can, like I try to be responsible over email. So if you like, just tell me like I tried this. This is what I get. Like you need to show me the code you ran and the output you get. Sometimes I only get like bits of information. Like I get the error message, but I don't know what happened. Just give me all parts of the information and I'll try and figure it out and I'll give you an answer. And if I don't, I'll ask for more information. But any questions you have, just let me know. Okay, I'm gonna turn to the practice bit. Young-san, can you tell me what you were seeing, or like if you can share your code, even better.
Yeah, so I first looked for a sibling because I didn't know which variable I had to code, and it gave me P1 sib. So
yeah,
I ran this reverse math.
We can't see your screen, but if you can share it, that'd be great.
I put it in the chat right now.
Oh, okay. Yeah, that works.
And then it gave me the results for the regression, and it came out with the coefficient of -0.81. So I was guessing the more number of siblings you have, the math score decreases.
Yeah, that is the right interpretation. Right. This is what you're seeing, right?
Yeah.
So this is what. So you found the right variable. You knew that it was this P1 numsib, right? You found the right coefficient. It's a little weird, right? And it's significant. So what happens when you control for, say, SES and we can show that. It's control for SES and it's still negative, right?
Yeah.
Now, look for age. If you look around, there's one for HMA. Mothers, this is parent 1, their age at first birth. What do you, I mean, you already have the code in front of you, but for others, what do you think will happen when I enter this? When I also control for mother's age at first birth? Any guesses? Like what's going to happen to the main coefficient of our interest, the number of siblings? More negative, less negative, no change?
Less negative
Less negative. By a lot or by a small amount?
by small.
Yeah. And do you think you can try and explain why doesn't this change very much? I mean, it changes somewhat. Why does this not change so much? It's pretty similar.
Because they aren't related, the control variable and the.
What's the day here? The control variable and math2?
Yeah. The control variable and the outcome, right?
So yeah.
Yeah.
So let's do this. So we'll look at the same relationship, right? And then we'll only control for mom's age. And if you're correct, this should not change much, right? Because this is not closely related. This is the age variable. But it changes now a fair amount. So your hypothesis that mom's age at first birth is not related to a child's math2 doesn't exactly hold up because that's a big change. So why, after we have regressed this math2 on mother's age, or on the number of siblings, we've controlled for SES. And now we have added mother's age at first birth. Doesn't change so much, right? It changed a lot before, but it changes less here. Why?
Because there's less to control for the variance. The other control variables already explain some.
This is true. You're correct. But right, so she just said, well, there's less to control for because I forget your exact words, but because other variables in here are already sort of explaining the outcome. But which variable is doing the job of mother's age at first birth?
SES.
SES? Can you say more?
So maybe they are all related to each other. So maybe like moms who gave birth in younger age are in the lower SES. Maybe, and like they are SES and age are related to each other. Right?
Yeah. So you already have an SES variable, which is sort of, it's not a real variable, right? It's just a composite of information. And part of that information could be about maybe teenage moms or moms who had babies like earlier than average. And that's related to SES. So you're already explaining a lot of it with this composite variable. And so it changes because it's adding in new information, but not as much as you would think. So the next question is, we have this now, and it's still kind of weird that the number of siblings that you have is related to like a lower math score at math2. Is there a control variable that you think is relevant here that might change this relationship? Like what else could you add? Or would you take it that even though it's not causal, that the number of siblings might be influencing your math2 score?
Are we supposed to look at the variables that we have in the data set?
You can like look for, as if you were like Googling, look for, age, look for, you can look for it, you can go through a list, or you can like think conceptually about it, then look for it.
So can you ask your first question again?
So the question is, it's like, would you believe this result, or would you say maybe maybe you didn't control for something. And so what else should you control for that might meaningfully change the relationship between number of siblings and the outcome? Someone's in my
So,
chat
I mean,
window.
the less correlation that the variable has with the number of siblings, the better the control would be, right? Something like that. So if the more that it is not related to number of siblings, the better the control variable.
Yeah. Well, yes, because as long as it's related to math 2. Someone said child age. So I'll put in age here. That's child age. And now we're back to negative 0.5. It's weird, right? It's hard to predict what's going to happen here. So, like, is the relationship negative? So in the equation of y equals beta 0 plus beta 1 times x, or x whatever plus error, right? It's a question of like, what else is in here? Someone said type of care. So like, for care.
So we are trying to see if the relationship is causal or not.
The question is not whether the relationship is causal. The question is, this model tells us that this relationship is negative, right? And it's not about causality at all. It's just like, do you believe that people who are, who have more siblings do worse on math 2? And maybe this is negative and significant, highly so, because there's a lot of stuff missing that we didn't control for. And just intuitively, and this will come soon, very soon, what else should you be controlling for that's relevant to this model?
So it could be, I mean, the relationship could be there because like the more siblings that you have, so the harder it would be for your family to manage your education, and maybe like it affects your math score.
Yeah.
Somehow.
Yeah, and that's definitely true for some. Yeah. So the plan is less siblings and less babies. Other control variables you think are important? Someone said type of care. I assuming like type of care they had when they were younger.
Yeah, the reason I was just thinking type of care is I don't buy into the negative coefficient. I don't think you score worse if you have more siblings. It's ridiculous. So I'm wondering if it's type of care, because if you don't have like parental care looking after you, typically it's older siblings. So maybe that can affect your math score.
Right. So maybe we'll compare people who had similar care arrangements.
Mm-hmm.
It's still pretty negative. Other guesses? If you give up, that's okay.
But I mean, if we're just guessing here, we're talking about kindergartens and math scores. I mean,
yeah.
I mean, what kind of math are we talking about, right? It's first of all, right? And so
yeah, this is yeah.
So what are we talking about? Then also the first thing analysis that we ran as far as controlling for math, that makes sense because a lot of kids they may only have 2 months of schooling. They're just entering school at that point. And so some people have preschool, so it makes sense to do that. And what I would look for is maybe teacher quality. I'm not sure that it would make a difference at the level of kindergarten though. I think kindergarten entry is going to be the big one. I don't know if we have something that codes for years of experience or not in there. So.
Let me check. Look for your. I don't know that I have the teacher quality in here. It's likely in the full data set, but not in this like class data set. But you mentioned something which is like you can control for math 1. It was not in the model here. It was in the previous model, as you noted. And if you do, that relationship goes away. And so like these kind of correlational descriptive studies, it can be really misleading. It can be like super misleading, right? Just looking at it and someone will say it's significant, it's true. And you just keep thinking like something's missing. And oftentimes like a very important one is just a prior outcome. And if you don't control for the prior outcome, you just have a hard time understanding any of the covariates because they're not going to make any sense. And even if you do, there's the problem of compounds. But I wanted to sort of just go through this and be like, what else? What else? Just and sort of see the ridiculousness of what's happening to the coefficients and where the statistics have limitations. And you have to be skeptical. Cool. So that's all I had. Yeah, if there were any parts of what I went over today that were confusing or that you think would be useful if I went through again, I can do that. Or we can end it here and everyone can be on their way. If you think there's anything different I could be doing in lab to help you, let me know. I'll make those changes.
No, well done, Paul. Thank you so much.
Okay.
Okay.
Cool. All right. I'll see you guys later.
Thank you, Paul. Have a good one.
Okay. Thank you.
Thanks.
Bye.
Goodbye.
Bye.